Hi, Pre-Calculus. We are returning with our second video. Now we're going to look at function compositions. So this is a new operation. So I'm going to start by rewriting our two functions that we used in the last video. So f of x and g of x. So I have x squared plus 3 and 2x plus 1. Now we're going to use a new function, which is the composition. So that literally means we're going to be plugging one function inside of the other. So one will be the input for the other function. So the way we denote that is three different ways. So the first way is going to be the most explicit way. So we see f of g of x. So you see that g of x is inside of f of x. So kind of really shows clearly how we're going to put it together. My second notation is now we see this symbol where we use this open dot. Not a closed dot, but an open dot. That means the same as above. We're going to compose the function. So f open dot g of x. And then the other way to show it, is to do an open dot and just write f of g. So just like before, all three of these are equivalent. And just like with the other operations, they kind of follow the same formatting. Okay, so all of these again are equivalent. Now, what we're going to do is we're going to do actually composing these two functions together. So I'm going to start with this f of g of x. So the best way to approach this is by actually doing a substitution. So I'm going to substitute in g of x inside of f of x. So I go and I look at my function. What is g of x? So I'm going to go ahead and I see off to the side it's 2x plus 1. And now I'm going to substitute that 2x plus 1 inside of f. So I'm going to write it here, f of, and now what is g of x? It's 2x plus 1. So pretty direct substitution. Let me change that to blue. Here we go. So now I got to figure out, well, what is f of this 2x plus 1? What is that? I have f of x, but I don't have that. So I'm going to, just like before when we did function evaluations earlier on in the week, we're just going to substitute. So the best way to kind of look at it again is don't get hung up on x. Think of the x as a placeholder. So I like to write it like this fill in the blank. So wherever x was, it's a blank that we're going to fill in with whatever we decide to plug in. So in our case, we're going to plug in to these blank spots. We're going to plug in is our 2x plus 1. So let's do that. So 2x plus 1. And then the next blank, 2x plus 1. And right there, we did our composition. So all this is going to get written over here. So let me go ahead and change it back. So now I have it's 2x plus 1 squared plus 3. So right here, this is our substitution. All we've done in these first steps is just substitute. So this is our setup. Okay? So again, showing your steps and showing your partial work is going to get you some credit. Now, the next part is cleanup. I'm going to expand and collect like terms if possible. So with this, it is possible to collect like terms. So I'm going to start by expanding my 2x plus 1 squared. So off to the side, I'm going to go ahead and figure that out. What is 2x plus 1 times 2x plus 1? I'm going to use the box method here. Again, just to highlight that method for multiplying polynomials. So 2x, 1, 2x, and 1. We'll multiply, so this is 4x squared, 2x, 2x, and 1. And now we're just going to add all the terms that are in the boxes. So 4x squared, 2x plus 2x is 4x, and then a plus 1. Now don't forget, that's just the 2x plus 1 squared. I still have that plus 3. So plus 3. And now I do one more cleanup of the 3 and the 1. So 4x squared plus 4x plus 4. That is my final answer. So setup, then cleanup. All right, now what if I change the order of the composition? So the first thing to keep in mind about composition of functions is it is not commutative, meaning if we change the order of the operation, that it is not going to give us the same answer. So if I said g, so let me write it here, g of f of x, that is not going to be the same as f of g of x. So to show that, we'll actually do this composition as well. So let's go ahead and start to set that up. So I'm going to scroll over here. I want to be able to look at g of x. And f of x, we're going to substitute that in. So that's x squared plus 3. So our first step is, again, this substitution. And now, just like I did before with f, in green, I want to substitute this x squared plus 3, but this time into g. So I'm going to write g of blank equals, and now it's going to be 2 blank plus 1. All right, so again, anything that was x is going to be blank. And now we're going to fill in those blanks with x squared plus 3. And there we go. There's my composition. So there's the end of my setup phase. So I'm going to copy all this over, because this is g of x squared plus 3. So it's going to be 2 x squared plus 3 plus 1. So again, this is the substitution phase, the setup phase. So right here we've done the hard part. We've done is the composition. Now comes the cleanup. So the cleanup here is not as intense. It's just distributing the 2. So I'm going to do that. So 2x squared plus 6. And then the plus 1. And then we'll do one more cleanup. 6 plus 1 is 7. So right here you see they are two totally different functions at the end. So compositions are not commutative. Now, in the next lesson, we'll talk about what happens when they are the same that indicates a certain property. Some of you may already be familiar with what that property is, the relationship between two functions if their compositions were the same. But we'll get into that in the upcoming sections. But for now, you need to just know that they are not commutative. Switch the order and you will get two different answers. All right, so again, if you like the video, please make sure hit a like on the button on the button at the bottom if it was useful to you, and make sure that you are subscribed to the channel.